जय हिंद स्टूडेंट्स, आप लोग कैसे हैं? आई एम वेरी श्योर you all are studying very well and revising the taught topics thoroughly, right? Students, please devote yourself completely towards your studies. It is only through your hard work that you can achieve your success. With dedication and devotion, every dream of yours can eventually come true. So with that saying, let's start with this session. In the previous lecture, what we have discussed was, we have discussed the defects of human eye, myopia and hypermetropia, as well as we have discussed the causes for those defects and the cure of those diseases, eye defects, along with the ray diagrams, isn't it? We have also derived a mathematical formula for the power and the focal length of the lens to be used so as to treat myopic eye and hypermetropic eye. So let's make use of those formulas in solving these problems, right? And before we start dealing with these numericals, there is one more eye defect which I would like to explain. That is presbyopia. Actually, there are some other defects as well, like cataract, presbyopia, astigmatism, but I will restrict myself to presbyopia, right? So let's first discuss this topic briefly and then we'll continue with this numericals, right? So this is the third type of defect which we are studying. It is presbyopia. Students, we have already discussed the power of accommodation of human eye. It's a unique feature of our human eye that our eye can adjust its focal length or curvature or aperture so as to enable us to see both nearby objects as well as distant objects. That's the beauty of our human eye, and that is the property which is known as power of accommodation. But students, with the growing age, with the passage of time, what happens is the ciliary muscles get weakened, and due to this weakening of the ciliary muscles, the near point of the human eye starts decreasing or it starts deteriorating. So what happens is, with the age, with the passage of time, as the time passes by, particularly in the old age, what happens is, due to the weakening of the ciliary muscles, the power of accommodation of the human eye tends to decrease or it tends to deteriorate. So as a result of which, a person in his old age is unable to see the nearby objects clearly. So this eye defect, or rather this farsightedness, that is hypermetropia, which occurs due to the weakening of the ciliary cells on account of old age, is known as presbyopia. Right, students? Also, I would like to mention, there are certain instances when a person may suffer from both myopia as well as from hypermetropia. In such a case, the person needs to make use of both concave lens as well as convex lens. So in order to treat such eye diseases suffering from both myopia as well as hypermetropia, we make use of bifocal lenses consisting of both converging lens as well as diverging lens, right? The lower part of that lens is used for viewing the nearby objects, while the upper part of the lens is used for viewing faraway objects. It's somewhat like this. This is, suppose, a speck, and this is the part of the lens which is used to view the nearby objects. Obviously, this must be of convex lens. It must be of converging nature. It is used to see the nearby objects. It is used to see the nearby objects. While on the other hand, the upper part of the speck, it is of diverging lens. That is, it must be of concave lens. and it is used to see the distant objects clearly. Right, students? So basically, this is known as a bifocal lenses, making use of both converging lens as well as diverging lens of suitable power. So this lens is used by those persons suffering from both myopia as well as hypermetropia. Right? Okay, now we are in a position to discuss these numericals. Let's start with the first one. The near point of a hypermetropic eye of a person is 35 cm. What is the power of the lens required to enable him to read clearly a book held at 25 cm from the eye? Okay, so first and foremost, it is the case of a hypermetropic eye. It means that the person under consideration is able to see the distant objects clearly, but is unable to see the nearby objects clearly. And in such a case, we are aware he needs to make use of a convex lens, right? He needs to make use of a converging lens of a suitable power or focal length. And that is what our objective is, to find out the power of the lens required to enable him to read clearly a book held at 25 cm from the eye. 25 cm would be the least distance of distant vision, right? So the formula is power is equal to xb divided by x minus b. Actually, this is the focal length. This is the formula which we have already derived, right? The focal length of the convex lens, which is to be used to cure this eye disease, which is hypermetropia, is given by this particular formula. This we have already derived in the previous lecture, right? Let's now make use of this formula directly. So here, x is the near point, which in this case is given to be 75 cm. And d, as you are aware, it is LDDV, least distance of distinct vision, which for normal eye is considered to be 25 cm. It is actually the minimum distance from the eye at which an object kept from the eye can be seen clearly and distinctly, right? So that is 25 centimeters given. So the focal length of the lens to be used is f equals to xd, that is 75 multiplied by 25 divided by 75 minus 25. So it will give us 75 multiplied by 25 divided by 50. So it is 25 2, so it will be 37.5 centimeter. It's in centimeter. So now look, this is positive. So which type of lens is to be used? Convex lens. Convex lens is used to cure hypermetropia, right? So it is of which nature? Converging nature. So this is the lens to be used. Now here we are supposed to find out the power of the lens. Power, as we are aware, it's equal to 1 by f in meters. So since it's in centimeters, so it can be written as 100 by f in centimeters, right? In centimeters, it will be 100 by f. So what we get is P is equal to 100 divided by 37.5. So let's try to solve it. So it can be written as 1000 divided by 335. So 25, 40, 25, 1, 25, 1, 2, 5, 15. So it will be equal to 8 by 3. That is 2.67 diopter with positive sign. What it means is positive power. Power of a lens is positive for converging lens. So again, let me stress that in order to cure or rectify hypermetropia, the nature of the lens must be converging, having positive focal length and positive power. So this is the answer, student. This power of converging lens is to be used to treat this hypermetropic eye. Right? Okay, let's concentrate on the second question now. The far point of a myopic eye is 80 cm in front of the eye. What is the power of the lens required to enable him to see very distant objects clearly, right? So look, the person under consideration suffering from myopia. Now myopia, we have studied it in detail, that if a person is suffering from myopia, then he is able to see clearly the nearby objects, but is unable to see clearly the faraway object, right? So in such case, what happens is, the far point, which for normal cases infinity, it decreases for a myopic person, right? In this case, the far point of the myopic person is given to be 80 centimeter. So it decreases from infinity to 80 centimeter, right? And in order to treat a myopic eye, a diverging lens of suitable power is to be used, right? So, question number 2. Far point, that is x, in this case it is the far point. It has decreased from infinity to 80 centimeter for this myopic eye. And what is the power of the lens required? Now we are aware, in order to treat myopic eye, a diverging lens is used. And a diverging lens of focal length equal to the far point of the myopic eye. This we have already discussed, isn't it? This is the key. So, focal length of the lens to be used is minus far point is 80. So minus 80 centimeter. That's it. So negative sign suggests that it must be of diverging nature. It must be of diverging nature. That is, the lens to be used must be concave lens. It must be concave lens. Right? So, what about the power then? Power is reciprocal of focal length in meters. This is in centimeter. So, in order to change it in centimeter, what we do is 100 by f in centimeters. Right? So, power, it would be equal to 100 divided by small f in centimeters is minus 80. So it will be minus 10 by 8. So it is minus 5 by 4. So power is minus 1.25 diopter. So this power concave lens is to be used so as to treat this myopic eye. Right? Again, I repeat, the negative sign is suggestive of the fact that the nature of the lens must be divergent, that is, it must be concave lens. So if that person makes use of concave lens of power 1.25 diopter, then you will be able to see the distant objects clearly. Right? Okay, we are over with question number 2 as well. Now let's concentrate on question number 3. Question number 3 is, a person's far point is 2 meter and his near point is 50 centimeter, right? So, in this case, for a normal person, the range of vision, students, it is 25 centimeter to infinity. So, his near point is 50, more than 25 centimeter, and his far point is not infinity, less than infinity, that is 2 meter. So, this person must be suffering from both myopia as well as hypermetropia, right? So, such a person, in order to view clearly both the nearby as well as the distant objects clearly, must make use of bifocal lenses, right? That's a very good question. Find the nature of focal length and power of the lens he must use to see distant objects clearly. Okay, let's consider the first part. In order to see the distant objects clearly, he need to make use of a diverging lens. So, nature of the lens in order to see the faraway objects must be diverging. This we have discussed time and again. That is, concave lens is to be used. Right? No doubt regarding this. And what about the focal length and power of the lens? Focal length of this diverging lens, it should be equal to the far point of the person under consideration. So what is the far point? It is given to be 2 meter. So f, it would be equal to minus 2 meter. Right? So this is the focal length of the concave lens which is to be used by this person to see the distant objects clearly. Right? Now what about its power? Power is reciprocal of focal length in meters. It's already in meters, so no need to change it. So it will be equal to 1 over minus 2. So power would be equal to minus 0.5 diopter. So this is the answer of the first part. Negative sign of the focal length and power suggests that the nature of the lens must be diverging. So that we have already discussed earlier, right? So now let's try to attempt the second part. Over here, second part is the same person. Which type of lens is to be used by him to read a book clearly? Book is to be placed quite close to the eye, isn't it? So which type of lens is to be used by the person so as to enable him to see clearly the nearby objects? So in that case, he must make use of a converging lens. So nature of the lens in this case must be converging. That is, it must be convex lens. Right? So what is the near point given? Near point is given to be 50 centimeters. For a normal eye it should be 25. But the near point has increased for this person. So he needs to cure his eye by using suitable lens. So here x is 50 centimeters. So focal length of the convex lens to be used by him so as to enable him to see clearly the nearby objects is, what's the formula? X capital D divided by x minus capital D. So let's substitute the value. X is 50, it's given. LDDV, least distance of distant vision, which is the near point, is considered to be 25. Divided by 50 minus 25. So what do you get is 50 into 25 divided by 25. So it will be equal to 50 centimeters. It's in centimeters. So what should be the focal length? It should be 50 centimeters. Positive sign indicates that it must be of converging nature, right? So what about the power then? It is reciprocal of focal length in meters. So it will be equal to 100 divided by f, if f is considered in centimeters. So that will give us 100 divided by 50. So that will be equal to plus 2 diopter. So students, that's the answer of the second part of question number 3. I hope you have understood the concept. The only formula is to be used is, remember, only the formula is to be used is, in case the person is suffering from myopia or nearsightedness, then he need to make use of concave lens. And what should be the focal length of the concave lens? It should be equal to the far point of the myopic eye. That is, f should be equal to minus x, right? And in case a person is suffering from hypermetropia, then he needs to make use of convex lens. And in that case, the focal length is given by xd divided by x minus d, where x would be the near point of the hypermetropic eye. Understood, students? So only these are the two formulas to be used in numericals concerning eye defects, right? So let's try to attempt the fourth question as well. It is also based on the same fact. We'll be making use of the same formula. So the near point, fourth question is, the near point of a hypermetropic eye is 1 point. Near point is changed. It's increased from 25 centimeter to 1 meter. It means that the person must be suffering from hypermetropia, right? So question number 4. So he must be suffering from hypermetropia and near point is 1 meter. Near point or far point, both are represented by x. What is the focal length and power of the lens required to correct this defect? Now, as we have discussed, focal length to be used to correct hypermetropic eye is given by xd divided by x minus d. This is the formula to be used. D, that is the near point of the normal eye, is to be considered as 25 centimeter. It's given in the question. So, f is equal to, this is in centimeter, this is in meter. So either convert this in meter or meter into centimeter. We have to consider only one system of unit, right? 1 meter is 100 centimeter. So what we get is 100 multiplied by 25 divided by 100 minus 25. So it will be 100 multiplied by 25 divided by 75. So it is 100 divided by 3 centimeter. That is 33.33 centimeter. This is the focal length of the convex lens to be used by that person to treat his eye defect, right? So positive sign suggests that it must be of converging nature. Converging or convex lens, right? Okay, now we are also supposed to find out the power of the lens. Power, as we are aware, very often we have discussed, it's given by the reciprocal of focal length in meters. If it is in centimeter, then it will be 100 by f in centimeters, right? So power would be 100 divided by focal length is 100 by 3. So 100, 3. So 100 get cancelled, we'll get 3 diopter. So plus 3 diopter. So he need to make use of a convex lens of power 3 diopter, right? So students, I feel after doing these questions, you need to feel confident about yourself, right? Once you are able to understand the concept, just do numerical, just practice as many numericals as you can. That's the only way you can gain in confidence. So that's it for this particular session. So I hope you have understood the numericals and understood the eye defects in the previous session. This session also we have discussed another eye defect, that is presbyopia, isn't it? So all the best then. Do take very good care of yourself. Thank you.